I would also like to thank Mr. Manish Gupta and Professor J.P. Shivare, who also helped me in the research. I would also thank the co-authors Nishant Bhardwaj and Shubham Gupta for their support in the research. First of all, introduction. Tumor certainly in any part of the body, it can shed cancerous cells. Maybe it is in leg or in any part of the body, it will spread throughout the body through blood vessel circulation. These cells are nothing but cancerous cells, also known as circulatory tumor cells. Detection of cancer at earlier stages, generally it is not possible by the technology being developed yet, but still there are certain technologies which are coming up for the early detection of the cancer cells. Moreover, when the cancer cells are very small, they are nano cells or microscopic cells, these are very difficult to detect basically. So there are certain techniques which I will be discussing in the paper through which early cancer detection is possible. Moreover, there are certain conventional techniques also which I have discussed very briefly in the paper. Some of these techniques include magnet technology and spintronics, which is a hypothetical approach. Magnet technology, the two factors lying in head of magnet technology is basically the iron and the magnet. These two are the basic forces. Cell-stress test, which was given by Leon Tersteppen, was one of the very strong measure of cancer detection. The system comprises basically of two components in it, one which finds and flags the circulatory tumor cells in 7.5 milliliters of blood, and one which analyzes the cells. The test relies on the microscoping and nanoparticles. The sick part, or we can say the sick part of the cell or the disease part is tested. Is basically tested where upon the body immune system it develops the antibodies around it. These are basically defective cells. The antibodies will attach themselves to tumor cells but not to the healthy cells. They remain the healthy as in the same way. The tumor cells which have been labeled, they will be separated from a body by the function of iron and magnet policy. As a part of my intervention, if we increase the number of cell characteristics in the test, the more and more characteristic will determine the nature of the test, or we can say the preciseness of the cancer is very important in order to start up with this treatment. So the preciseness and the technology behind the cancer could be detected easily at an early stage. Spintronics is a totally new technology. Spintronics is spin plus electronics. Generally we talk about electronics. In electronics we will just take the conventional charge of the electron into consideration. In spintronics, we take the spin of the electrons also into consideration along with its charge. So this deals with the quantum aspect of the technology. The spin, the upper +1/2 and the lower -1/2. Spintronic applications are very rare. It is basically in the field of arrays, memory storage devices, and one of the applications which can deal with it is spintronic scanning technique, which is not yet fully developed. But this technique is generally we can say a hypothetical approach which can later come up. There are certain compounds which we can synthesize, spintronic compounds, which can help in this research. Cancer cells are easy to be identified only when they are large in number. This is the only case. In the case of radiography and other machines, when we are able to, we'll be able to detect cancers only when the cancer cells are very large in number. But when cancer cells are very minute in number, or after surgery of cancer or chemotherapy, there are certain small number of cancer cells which still remain. Thus, we can detect those cancer cells by the philosophy or by the technology of spintronics. These cells have then become matured in formation of high-level subsequent tumor, which has to be removed by surgery. The spintronic scanning is an efficient technique to detect cancer cells. Even when they are less in number, we can be able to detect those cancer cells. What is the basic process of spintronic scanning is that a patient is first of all exposed to a very strong magnetic field. When the patient is exposed, both the parts, the unaffected part as well as the affected part, are approached to a magnetic field. A beam of electron with polarized beam is radioactive material, generally fluorodeoxyglucose is used. And the second technology is MRI magnet resonance, that is the hydrogen atoms when they are immersed in water, they always produce a magnetic pulse. That pulse always is orientated with the spin of the electron. The conclusions are, we have discussed the conventional strategies for early cancer detection in the paper. Moreover, we have also focused on the latest technology interventions in the field of biological means. This paper also focuses on aspect of capacity of providing sensitivity, throughput and nanotechnology, which the cancer cells always have a nanothin particle. Moreover, we have also sent as a future scope, we have also sent barium titanate and bismuth ferrite samples. We have doped them with cobalt and we have sent them for testing of SEM. So SEM test, and basically we have also sent it to different labs for testing, and we have expected early results so that we can continue with this research. These are the references.
Is there any question from the audience?
Yes, where the cancer cells are distributed throughout the body.
Yeah.
Then in that case, how do we detect early detection?
That technology is yet to be developed, and that's a very good question indeed. We have that the cancer is present in the human body or not, these minute cancer cells, because sometimes the cancer cells are very less in number, and if they are less in number, we will be not able to detect them with efficiency with other machines, and they are not in that working state.
The leukemia, the mast cells and the hemoglobin, they are having some different spinning properties, or the various cells in the body which are actually cancer cells, are they having some different spinning properties